about titrations and titration curves. So from your initial handout, you had to define the following words: titration, equivalence or endpoint, your titrant, analyte, indicator, a buret, and a neutralization reaction. Okay, so all those words are also found in your textbook, in the index, glossary, and in the reading. In our case, in the chapter right now is chapter 18. Okay, so all those words you should be able to define and use appropriately. What you're going to do is you're going to do a lab, eventually where you're going to do a titration. And this is how it's going to be set up. You have your ring stand here. You're going to have a piece of white paper underneath. That's going to help you see the phenolphthalein change from clear to pink when it becomes a slightly basic solution. You're going to have an Erlenmeyer flask, in our case a 250 ml Erlenmeyer flask. And inside the Erlenmeyer flask is where you're going to put the titrant. Okay, so we're going to put our titrant in the bottom, and that's what you need to determine which is the titrant. Inside of our Erlenmeyer flask, we also need to put 2 drops of phenolphthalein. That is one of our indicators. Our indicator here, since we're testing to see when our acid becomes a base. Okay. We have here is a buret. Okay, it's a long skinny tube, but it has graduations on it, so we can measure our initial amount of analyte is what goes in the buret, so our initial amount of analyte, and then our final amount of analyte, the difference between the two being how much was put in here. We can control the flow of our buret by twisting the stopcock. That's a little dial on the side that we twist. If you twist it very quickly, then just a couple of drops will come out. But if you twist it and open it up, the flow will come down and then you can twist it again. So that's our buret. To our ring stand, we have a buret clamp, and we squeeze the clamp, and that releases the buret. So you want to have one hand on your buret when you squeeze the clamp to release it to pull it down, and then you want to squeeze the clamp again to push your buret back on. You want your buret to be about eye level, so that way you can easily read the level of analyte in your buret. Okay, so this is what it should look like. You're going to want to have this diagram for your reference, especially for when you do the lab. Alright, the information we get from doing a titration leads us to make a titration curve, which helps us identify our acid if that's unknown, helps us narrow it down. For titration curves, we are controlling the amount of milliliters, so the volume of our known concentration of, in our case, base or our analyte, and we're applying that against the pH. In our case, for the experiment we're going to do, the pH just changes from acid to base, and we know when we reach the endpoint or the equivalence point, because that's when our indicator turns pink. In this case, looking at titration curve, your endpoint or equivalence point is at the point of inflection, or when the slope changes from a positive slope to a negative slope. Okay? If we were to have, this is for a monoprotic acid that just has one point of inflection, one endpoint equivalence point. If we were to have a diprotic acid, here notice we'd have 2 endpoints or equivalence points, like in graphing pH by the whatever known molarity of analyte, in our case, base, added. And if we had a triprotic acid, we'd have 3 endpoints, or a triprotic base as well. Okay? Again, graphing how much of our analyte we put in versus the pH. So there'll be some examples of a monoprotic acid. Well, monoprotics tell us that we would have 1 ionizable hydrogen. So examples would be hydrochloric acid or hydroiodic acid. Diprotic acids have 2 ionizable hydrogens, so sulfuric and sulfurous acids. Triprotic acids have 3 ionizable hydrogens, so phosphoric acid and phosphorus acid are 2 examples there. So you want to be able to determine what kind of acid is being displayed by a titration curve, and given examples of mono, di, and triprotic acids.